Hey there, automation engineers. Look, if you've ever been tasked with building or maintaining an industrial control system, you know the drill. Setting up that foundational software structure, it's kind of like assembling this incredibly complex puzzle where just one wrong piece can literally bring the entire plant down. Nobody wants that, right? So in today's explainer, we're going to completely decode the complex architecture of Simatic PCS7. We're taking all those abstract software concepts and turning them into a clear, absolutely foolproof structural blueprint. Think of this as your masterclass in industrial software architecture.
Okay, let's dive into this. We're putting on our master architect hats today. We aren't just writing code here. We are physically structuring an industrial software facility block by block. Every automation system, every single operator screen, and every network connection has its designated place. And when you architect your system correctly right from the ground up, well, expansion, teamwork, and commissioning all become completely seamless. So here's our game plan. First, we'll look at the master multi-project container. Then, projects, libraries, and stations. Third, topologies for distributed engineering. Fourth, system construction and expansion. Fifth, system-wide synchronization. And finally, number 6, we'll wrap up with the architect's golden rules. All right, kicking things off with section 1, the master multi-project container. So the multi-project container basically acts as a giant, transparent bounding box. Think of it as the ultimate master integration layer for your whole setup. Inside this secure, unified environment, Simatic Manager seamlessly houses two distinct but totally vital components. Your user project, which contains your actual programming and charts, and your master data library, which holds your standardized blocks. You should absolutely always use a multi-project for configuring with Simatic PCS7. Why? Because it allows all these separate pieces to interact beautifully within one single unified tree structure. Moving right along to Section 2, Projects, Libraries, and Stations. Now, before we even look at the layout, let's make sure we clearly define the intellectual difference between our two core elements here. They live side by side, sure, but they do completely different jobs. A project houses the actual plant execution logic. This is where your programmable devices live and where the real-world action actually happens. A library, on the other hand, that's simply a standard repository. It holds predefined reusable functions. It doesn't execute anything, and you literally can't test or debug inside it. Visually, the distinction is actually pretty striking. Both elements share a foundation. They're stored in a single directory and managed via Simatic Manager. But the project is this active folder of executing data. While the library, well, it's basically a reference book on a shelf, just waiting for you to pull standard functions from it. Keeping this distinction crystal clear in your mind is absolutely crucial for an organized build. Now, within those projects, you're going to deploy 3 main station archetypes. First up, the AS, or automation system. These are represented by your Simatic 400 stations for distributed I/O and process execution. Next is the ES, or engineering system. That's the PC where you actually configure the blueprint. And finally, the OS, or operator system. These are the WinCC screens your operators will use to monitor the plant. Now listen up, because there is a massive pitfall here that traps so many engineers. Never, ever directly select OS from the Insert New Object menu. Every operator system must always be inserted as a PC station first. Bypassing this is a really common, costly mistake that'll completely break your integration. Okay, Section 3, Topologies for Distributed Engineering. So let's talk about the labor force. Notice the strategic advantage we have here. A central multi-project server allows you to divide and conquer. You can literally detach a user project, hand it off to an engineer to configure offline, and then seamlessly merge it back in. But how do we actually organize those folders? Well, you've got a choice between a project-specific structure, which mixes automation and operator systems together, or a station granular structure that keeps them completely segregated. And I want to pause right here and be incredibly direct for a second, because this is a non-negotiable best practice straight from Siemens. You must default to total segregation. Use a station granular structure. That means exactly one user project per station. Why? Because when you finally hit the commissioning phase, mixing AS and OS objects in one project creates endless workflow bottlenecks and just massive headaches. Total segregation gives you the maximum flexibility you are desperately going to need later on. All right, shifting gears to Section 4, System Construction and Expansion. Simatic Manager gives you 2 ways to build. First, there's the New Project Wizard, which is fantastic for rapid construction. It lets you select your CPU, define your plant hierarchy, and set up your OS architecture in literally minutes.
but it does place everything into a single user project initially. Then we have the manual expansion paths for adding custom integration. Now, wizards are undeniably fast, but you need to be aware that they have some critical blind spots. Which brings us to a massive golden rule alert. If you take nothing else away from this construction phase, please remember this. The wizard does not automatically create the subnet object for your industrial Ethernet plant bus. You have to step in and manually insert this via Insert New Object in your hardware config. If you forget to do this, your beautifully architected hardware is going to be completely disconnected and totally incapable of communicating. No way around it. Now, what's really interesting about this build phase is that you're actually managing two parallel configuration tracks. Let's look at the top track first, the automation system. You start by selecting your library, creating the multi-project, configuring the hardware, creating the plant hierarchy, assigning resources, actually programming the software in CFC or SFC, and then finally moving to testing and commissioning. Parallel to that, you have the operator system configuration track. You create those PC stations we talked about earlier, configure that specific hardware, make your basic WinC settings, insert your picture objects, and then execute an incredibly important step, compiling the OS. Only after that do you move to final testing. So you might be wondering, how do these two independent workflows actually connect? Well, here is exactly how they merge. Following the timeline, we have our AS configuration steps in teal and our OS configuration steps in orange. They ride along this dual-track highway totally independently during the heavy lifting of engineering. But notice where they finally merge, right at steps 6 and 7. The software is configured, the OS is compiled, and those parallel paths come together seamlessly for system-wide testing and commissioning. It's really a beautifully orchestrated workflow. Moving right along to Section 5, System-Wide Synchronization. The real hero of this synchronization is the master data library. Think of this as the blue book of your entire system. It acts as the single source of truth for all your system-wide standards. It holds block types, SFC types, and crucially, shared declarations like engineering units and equipment properties. You manage these centrally in this one blue book, and then systematically push those updates downward to Project A, Project B, and Project C. And here is another strict, critical limitation. In any given PCS7 multi-project, you can only define exactly one library as the master data library. Please do not try to get clever and designate multiple masters. If you do, your synchronized standards will instantly corrupt, your units will clash, and your single source of truth becomes this chaotic argument between conflicting files. One system, one master, that's it. This synchronization ensures two massive real-world functionalities. First, it allows your logical subnets to communicate. By using the merge subnets command, networks created in separate distributed projects will share the exact same S7 subnet IDs. Second, it manages your global display languages. And the stakes here are super high. If you don't explicitly select your display languages across your projects before compiling the OS, those message texts go to the completely wrong column. What does that actually mean for you? It means plant floor operators will be staring at blank WinC screens during a critical process instead of seeing the data they need. Not good. And finally, Section 6, the Architect's Golden Rules. Look, your master blueprint is totally useless if it gets accidentally overwritten. You must institute a strict archiving cadence. Back up your data at least once a day, and always before and after downloading to the AO or upgrading software. The golden rule here is to keep at least the last 3 versions as backup copies. When you use the retrieve command in Simatic Manager, it actually derives a new subdirectory name from the multi-project name, which fundamentally prevents you from catastrophically overwriting your active project with an old restored backup. So let's rapidly synthesize everything we've learned into the ultimate architect's checklist. 1. Default to a station-specific topology for maximum flexibility. 2. Never bypass the PC station when creating OS servers or clients. 3. Remember the wizard's blind spot and manually build your industrial Ethernet plant bus subnets. And 4. Vigorously protect the single master library as your only source of truth. So take a step back and think about the systems you're managing right now. Looking at your own automated plant architecture today, is it a master blueprint built to scale or house of cards waiting to collapse? Keep these principles in mind and you'll always build on a solid foundation. Thanks for joining me on this explainer and happy architecting.